Imagine for a moment that you are this young guy standing in front of this tall tree. The tree is really tall. And you have this funny feeling or this funny idea. You want to know how tall the tree is, the height of the tree. But you and I know that you cannot just jump to the top of the tree, take a tape measure or something, and measure from the base to the top. You cannot do that. So as you're wondering how tall the tree is, we have a valid question for you. How can we measure something that we cannot reach, like this tall tree? We cannot reach the top of the tree. So how do we measure something that we cannot see? The simple answer is trigonometry. Mathematicians came up with trigonometry to help them measure things that are quite impossible or difficult to measure directly. You can't just take from the starting point to the ending point and measure directly. So anything that is quite difficult to measure directly, they use trigonometry and the trigonometric ratios to measure them. That is the tree scenario. Or let's say you go to Egypt and you are standing in front of a tall pyramid. And you are wondering how tall the pyramid is. You want to know how high is it from the base to the top. How will you do that? Meanwhile, you and I know that you cannot jump to the top and just take a tape measure and do that. Also, you use trigonometry. Trigonometry can help you measure or estimate the height of the pyramid by knowing some few parameters. So in this lesson, as we are wondering the height of these stuffs, we'll be considering what trigonometric ratios are in this particular lesson, and also look at sine, cosine, and tangent. And we'll see how sine, cosine, and tangent relate angles of a triangle to the sides of the triangle, but more specifically, right-angled triangle. So now let's get started and move on to the first thing we have to consider. That is a right-angled triangle. What is a right-angled triangle? We need to understand right-angled triangle so that we can consider the trigonometric ratios. What is a right-angled triangle? A right-angled triangle is a triangle that has one of its angles being equal to 90 degrees. And it's called triangles because there are three angles. So it has one of its sides equal to 90 degrees. And then the side that is directly opposite the 90 degrees is known as the hypotenuse. So the hypotenuse is the side of the triangle that is directly opposite the 90 degrees. Now the triangle or right angle triangle has other two angles, the one down here and the one at the top. So far we've seen the two parts of a right angle triangle. Each side which is 90 degrees or which each angle which is 90 degrees, and then the side directly opposite the 90 degrees, which is the hypotenuse. Now, assuming we are considering the angle at the down, which we've labeled as theta. Assuming we are considering that angle, theta. The side of the triangle that is directly opposite the theta. So you see where the theta is. The side of the triangle that is directly opposite the theta is known as opposite. And then the side just below it is known as the adjacent. So these are the main parts of a right angled triangle. We have the 90 degrees, and then the side directly opposite the 90 is the hypotenuse. And then assuming we are considering the angle at the down, labeled theta, the side directly opposite is known as what? Opposite. And then the side below it is known as what? The adjacent. But here's the interesting part. Assuming we do not consider the angle at the down, but we rather consider the angle at the top, then here's what happens. Then the side directly opposite that angle, which is the side at the down, becomes the opposite. And then the side beside it becomes what? The adjacent. So what it basically means is that for a right-angled triangle, the opposite and the adjacent depends solely on the angle we are considering. Keep that in mind. The opposite or the adjacent depends on the angle we are considering. So I think that makes sense to you. If so far you don't get what we mean by opposite, hypotenuse, adjacent, the theta, you can write it in the comment section. Or better still, we'll leave a link to a WhatsApp group in the description. You can click on that link and join the WhatsApp group so that you can ask any valid question that I have concerning this lesson. Good. So now we understand what a right angle triangle is, and then the various parts of it. Take time, absorb these things, and let's move on to how to find the trigonometric ratios. So that's what we are going to do next. Trigonometric ratios. Remember we said a right angle triangle has one of each side being equal to 90 degrees. Because of this 90 degrees, it gives right angle triangle a special kind of properties, special set of properties. And these properties connect the sides of the triangle to its angles. Now, what I want you to do is get a pencil, a protractor, a ruler, and a plane sheet. This side is going to be a lot of practical steps. You have to follow me along the lesson. I want you to draw a triangle, a right angled triangle. So draw a straight line and draw the 90 degrees and then measure an angle 30 degrees. Just use your protractor to do that. So draw a straight line, draw a triangle that has its angle, the base angle at this side being 30 degrees like I've labeled. And I'm sure you know how to use your protractor. So good. If you are done measuring this 30 degrees, you can draw any length that you want. But for me, when I measured the length of the sides of the triangle, I've gotten the base being 5.9 centimeters, and then the side being 3.4, and then the slanted side being 6.8. So you don't necessarily have to get these values that I got. Yours can be any other value, it doesn't matter. Just draw a right angle triangle that has the angle we are considering being what? 30 degrees. I hope you are done. And you are done measuring your sides. Good. Remember, the values of the sides do not need necessarily to be mine. They're the same as mine. Just make sure you get precise and correct what values. That's all. Good. Now, let's label this part. The slanted side is called the hypotenuse. Then the vertical side is known as what? The opposite. Why? Because it is opposite the 30 degrees. Good. It's opposite the angle we are considering. Then the base side is known as the adjacent. So now we've seen all the parts labeled. A long time ago, mathematicians did something interesting, and that led to they discovering the trigonometric ratios, or coming up with trigonometric ratios. What did they do? They picked the sides of the triangle and tried to manipulate or divide them by each other to see what they will come up with. So the first thing they did was they took the opposites, the opposite side, and then divided it by the hypotenuse. They picked this opposite and then divided with the hypotenuse like this. Opposite divided by hypotenuse. And our opposite is 3.4. Divided by the hypotenuse 6.8. If you point this on the calculator, you get 0.5. 3.4 divided by 6.8, you get 0.5 something. Good. But I've picked one decimal place. So you two, the value that you got for the opposites, any value that you got, divide it with the hypotenuse. Write what you got in the comment section. Let's see. Did you also get 0.5? Did you also get 0.5 something? Or you got more than 0.5 or less than 0.5? For this lesson, my focus is on one decimal place because these measurements, I've not gotten them very precise, but they will still help us get to understand how they came up with the trigonometric ratios. Then after they were done dividing the opposite and the hypotenuse, they now picked the adjacent and then divided it with the hypotenuse like this. They picked the adjacent divided with the hypotenuse, which for my own 5.9 divided by 6.8, and for me I've gotten 0.86. 0.86. So now your own, when you divide your adjacent by the hypotenuse, what did you get? Did you also get 0.8 something? 0.8 something. Write in the comment section. If you've gotten it, give it a just drop yes. Good. After they were done with this, they were just trying something. They have this strong belief that there is some kind of connection between the sides and the angles. So they were just picking the sides and dividing them. Then what they did next is they picked the opposite and then they divided it with the adjacent to see what they will get. For mine is 3.4 divided by 5.9. 3.4 divided by 5.9 for mine, I got 0.57 something, but I've picked only two decimal places. 0.5, 0.57. So now your value, your triangle that you drew, that's why I say you have to practice with me. Draw a triangle. Just make sure the angle is 30 degrees. And then the length can be the same as mine or different. And go through this process and see if you get these values. Good. So the mathematicians did this. And then they went on to do something. They use a special kind of function, special kinds of functions known as the cos function, the tan function, and the sine function. A function is basically a set of mathematical rules that receive a certain kind of input and gives an output. It receives one input and gives what? One output. And if you check your calculator, the calculators that you use, there is a section of it with those buttons. They've written is sine, cos, tan. I'm sure you found them. Sine, cos, tan. They have some algorithm behind them. And we don't have time to go into the algorithm because we really do not care about how they came up with it. But if you want to read more about it, there's some kind of interesting history behind how scientists came up with cos, tan, and sine. But for you, the algorithm has been done for and written already. So yours is just to use it. So you are going to use cos, sine, and tan. They are trigonometric functions. They take an input, and the inputs they take are always angles. So they can take sine, then the angle, tan, then the angle, cos, then the angle. Good. So for us, our angle, which is theta, is 30 degrees. So we are going to pick these functions and put 30 degrees into them one by one and see something. So let's pick the first one, sine 30. Take your calculator and punch sine 30 on your calculator. For mine, the angle I'm using is 30 degrees. So sine 30 gave me 0.5. Sine 30, 0.5. Then I'll move on to cos. Cos 30 again. Give me 0.866. And then tan 30 gave me 0.57 something, but I've picked only 0.57. Now, do you see something interesting unfolding? Can you see that the value for the sine 30 is 0.5, right? And the value for opposite over hypotenuse is also 0.5. Good. Now, look at the cos 30. The answer for cos 30 is 0.866. This is the same as the answer for adjacent over hypotenuse, which is 0.86. Now, tan 30, 0.57 is the same answer for the opposite over adjacent, 0.57. Good. Now, you might be thinking this works for only sine 30. I'll be giving you an assignment by the end of this lesson. So take your time and see. So when scientists realized this, or mathematicians realized it, they repeated the experiment for different sizes of triangles. They increased the size of the triangle. For example, they still kept the 30 degrees and increased the length. They increased the hypotenuse, increased the opposite, increased the adjacent. They made the triangle bigger, but they kept the angle the same. When they did that, they realized that the answers they were getting were still related. So what they came up with is this. That means if you pick sine theta, it gives you the same answer as the opposite of the triangle divided by the hypotenuse. Do you get that? Let me repeat. They realized that when you pick sine theta, the theta is the angle, the answer you would get is the same as the answer you will get by dividing the opposite and the hypotenuse. So they realize this. Sine theta gave us the same answer as opposite over hypotenuse, meaning sine theta is equal to opposite over hypotenuse. And then they realize that the cos theta, which for us cos 30 gave us 0.86, the adjacent over hypotenuse gave us 0.86. So that means cos theta is the same as adjacent over hypotenuse. And then tan theta is the same as opposite over adjacent. If you have been following me so far, when you drew your triangle, no matter how big it is, did you also get the same set of values? If you actually followed me correctly and used maybe 30 degrees and you went through the steps with me, irrespective of the length of your hypotenuse, adjacent, opposite, you should get this things. So now scientists said, oh, okay. So that means this is the relationship between the sine of the angles, the cos of the angles, the tan of the angles, and then the sides of the right angle triangle. Remember, right angle triangle. But mathematicians came up with an easy way of remembering, and that is SOH CAH TOA. SOH CAH TOA. So if you pick the SOH, the big S is sine. Then the OH means opposite over hypotenuse. So if you remember SOH CAH TOA, you know that the SOH means sine theta equal opposite over hypotenuse. Then the CAH, CAH, is cos theta equal adjacent over hypotenuse. Then the TOA means tan theta is opposite over adjacent. So if you remember SOH CAH TOA, you find it easy to remember the trigonometric ratios. So what we have on the screen right now is what we refer to as the trig ratios or trigonometric ratios. We've just found how they came up with it. So the easy way of remembering it is SOH CAH TOA. The trig ratios is so important because as a physics student, you'll be using it in resolution of vectors. And that will be our next lesson, how to resolve vectors using the trig ratios. Resolution of vectors. When you get there, we'll explain what resolution of vectors mean into detail. So subscribe to the channel. Subscribe and put us on post notifications so that when we drop a lesson, you can see it immediately. Now you've seen how we came up with the trig ratios using this triangle. I want you to try with a bigger triangle. If you like, you can draw a triangle, right angle triangle. Remember, right angle triangle. One of it should be 90 degrees. And then you can pick 60 degrees, 30 degrees, 25 degrees, 15 degrees, any angle that you want theta to be. And then go through the steps that we went through and see whether you will come up with the trig ratios or not. So this brings us to the end of how we came up with trig ratios. Remember, trigonometry helps scientists to measure stuff that they can not easily measure directly. So these trig ratios will help scientists measure things like the height of a building, or let's say a ladder is leaning against a wall, how high it will reach, or the height of a pyramid, if they know its angle, that the angle they are viewing from, and then the what, one of each sides, yes, or two of each sides. So basically, that is the idea about trigonometry. This sounds more theoretical, but in our next lesson, we'll be looking at resolution of vectors. You see how we use trig ratios to resolve vectors practically. So subscribe to the channel, give it a thumbs up, this video a thumbs up, share it with your colleagues so that they will get prepared for our next lesson. See you in our next lesson.